Hey guys, welcome back to my YouTube channel. So today in this video, we'll solve Leetcode problem 938, which is range sum of BST. So BST is binary search tree, and this is a binary search tree which you can see right here, which starts from 10. And a binary search tree is basically, I'll just give a short introduction. So you have to start with the value, right? Let's say here it's 10, and then you have to put all the values. So if a value is smaller than 10, then you have to put it on the left hand side, and then if the next value after that, if it's greater than 10, then you put it on the right hand side. So 5, then after 5 you see 15 is here, right? And then you see 3. So is 3 smaller than 5? Yes, you put it on the left hand side. Then 7, it's greater, then you put it. So all the greater than value right hand side and smaller than on the left hand side. So after 15, this one you say is 18. Up to, for 18 you put it on the right hand side. So you see, so to solve what the task here is to solve this binary search tree with the condition that they have given us two values. One is low value and the other is high. So low is 7 and high is 15. So you want to find the sum of all the values which are between 7 and 15, including 7 and 15. So which will be the sum of 7 plus 15 plus 10. So which will be 32. 7 and 15, 22 plus 10, 32. So you can see 7, 10 and 15, they come between 7 and 15. So that's all you want. And now the problem is you need to solve this binary search tree. And to solve binary search tree, there are two methods to solve it. One is either use breadth search method or depth search method. So in this problem, for this problem, we'll use depth search method, which will help us to eliminate the time and get a faster solution. So we'll use DFS, which is depth search method. And depth search method, what it does is, so let's say you start with a node. So in binary search tree you have a node, right? Every time you have a node and you compare all your left and right values using this tree. See, if this dot val, this dot left, this dot right. So forget about it. So what happens here is, let's say you have a value 10, and then what you do, you go and see, okay, right now low value is 7, right? So we'll put a condition that if the value, if it's greater than equals to 7 and less than equals to 15, then you add this value. So it will add 10. Yeah, then we can do the same thing again and again. And but what we'll do to eliminate the time and to get a faster result, we will put a condition that if the current value, which is node, basically what we want to do, we want to compare it to the low value. So we want to say if low value, if it's smaller than node value, so basically the lowest value is 7. So we are saying if 7 is smaller than 10, then you go towards the left side, right? If not, then you go towards the right side. So this is a popular method which is called before after, like how you put the node value. So here what we are doing, we're going towards the left, center, and then right. So we'll see left. So we'll say that is 7 smaller than the node value? Yes, it is. So we can go towards the left. So when we go towards the left, we come to 5, right? The node value is 5 now. We say is 5, right? So now this time we say is 7, again the low value. Is it smaller than the node value? It's not, right? Then what we say, okay, then there's no point of going towards this value because we don't want this. We want 7 or greater than it, right? So we'll say, okay, then you can go towards the right. And then we'll say for right hand side, we'll put a condition that is the right hand side, which is the high value, is the high value greater than the node value? So right value is 7. Is 7 basic? So right hand side is 7, right? So we are saying is 15 greater than 7? Yes, it is. So we'll add 7 to it, the node value. Then we go up to the tree again, and then we say is 10. So basically we say that is 15, which is our high value, is it greater than 10? So we say yeah, it is. So then we go and make this as a node value and add it. And then other time we again, next step is we say is 15 greater than 18, which is not, right? And then we eliminate it there and we add all the values and return it as a sum. So that's all, and I'll start it now. So I'll declare a variable sum as 0. Right, I've given a dot here. So this is pretty easy solution. Once you get the logic behind it, we'll declare a function. This function, it's a helper function for this bigger function, which will every time take a node value. So I see every time we got a node value and we need to check through those conditions and see if the logic is correct. So we'll say DFS and it will take node, right? Node is the current value where the binary search tree is, and it's checking left and right. So if that is the condition, we want to check first things first, that if we have got a node value there or not. Like, it could be null, right? And we don't want to check null is not a, we cannot check through null. So we want to check if it shouldn't be null. But if it's null, then we just want to return nothing. We don't want to return anything. We want to check other conditions. So other conditions would be that we would check if node dot value, right? We want to check if node dot value is greater than equals to low value, right? And so basically what we want the node dot value, this 10, right? Any of the value which is, it should always be greater than equals to 7 and less than equals to 15. So we'll say and node dot value should be less than equals to high, right? These are the only conditions we have got. And if this is the condition, that what we want to do is we want to add that node value to the sum, and we'll do this easy. After this, I want to, now what I can do is I can literally call DFS the method and put node dot left here, right? And then I'll call DFS node dot right. So what this will do, it will go towards all the left values and check with the condition that if it's greater than or not, and then check towards the right hand condition if it's greater than or not, and at the end we'll get the answer. So this DFS dot left and then DFS dot right, and after this basically what will happen, we will take this one, and once we'll get out of this function, we want to call it again for the root method this time. So we called for left, we'll going through the left, then we're going to the right, then we're going to the node, and then we'll go DFS root, right? And then what I want to do is I want to return, and what I want to return, I want to return the sum, because every time I'm adding into the sum. So I'll say return sum, and if I run the solution, then it should work. See, it did work. But in this thing, what happened, so when we did this, it went through all the left values, then all the right values, and then it added the node. But we can save some time by doing what? We can put a condition here, if condition. So I can put a if condition that here, if you can put a if. That's why it's one of the advantages to use by this depth search method. So you can put a if condition that if low value, if it's smaller than node dot val. What does it mean? Let me show you. So what it means is if node value, right? If low value, so what is low? Low is always 7. So if 7 is smaller than node dot val, so 10, is 7 smaller than 10? Yes, then only you go through it. So in one scenario, let's say it's here, so we'll say is 7 smaller than 5? No, then we will eliminate this and we will go up here and directly go here and save one step. Same we'll do for the right hand side. We'll say if high is greater than node.val, then only you want to go towards the right node, right? And so it also equals the equal sign as well. Greater than equal is same thing, and that's how it will add 10, 18 and 7, because it will be node at the time and we are adding the node value as well, root value. Now if you run, it should also work, and this time it's gonna save us these extra steps and save us some memory. And if you submit the solution, it should work. And yeah, see, that's our solution. So hope you liked my way of explanation and you understood BST and how we use DFS. It's called recursion. We are using calling the same DFS helper method function and calling it again till we go to end of the root. That's it. So if you liked my video, if it helped you in any way, make sure you subscribe my channel. That gives me the motivation to keep posting videos like this. Like it and share it to your friends. See you again.